So here's the video on how to analyze your AC circuit in MULTISIM. Okay, so for example, if let's say I would like to model this circuit, I would like to construct this circuit in MULTISIM. So firstly, you need to open your MULTISIM, and then we got this here. Okay, so this is the circuit that we want to model. Okay, so to get the component, so you need to go to either, yeah, maybe you can choose the any component here. So first I would like to add on AC source. Okay, so go to place source here. Okay, and then make sure that you are in the correct group, which is group source. Okay, and then under this you can choose the power signal voltage source. Okay, and then select AC voltage component. Okay, and then we place it here, and then we also need another one voltage source. Okay, so this one, to rotate you can press Ctrl R, then you can rotate the component and place it anywhere. Just follow the circuit event. Okay, next, let's say you have AC current source, so you need to choose this. Go to signal current source and select AC current, this one. Okay, so for this circuit we only have two voltage source. Okay, only voltage source. Okay, and then don't forget your ground. So under the same group, which is under source, so we need to choose ground. So you can choose under power source and select group, ground. Okay, this one. And then next we need a 4 ohm resistor. So 4 ohm resistor, you need to change the type of group. So choose basic. So under basic, you can find your resistor at here, and then you can add on the value of the resistor. So for this one we need 4 ohm resistor, and the other one is 2 ohm resistor. So just place it here, and then the other one is 2. Okay, so this one I want to rotate it and place it here. And then next we need the inductor. Okay, J or 4J inductor. Okay, so this one, since the value given is reactance value, so we might need to calculate what is the value for inductor in farad and capacitor in Henry. It's opposite. Capacitor in farad and inductor should be in Henry. Okay, so substitute in the formula to calculate XL, which is J omega L. Okay, so for this case, for this case, we don't have, the question does not provide the omega or frequency, so maybe I can set the frequency as 10, omega as 10. So to get frequency, f equals to omega divided by 2 pi. So this is 10 divided by 2 pi, 1.592. Okay, so for your assignment, the omega is given, so you can just insert your the omega or frequency given. Okay, so to get L, we have to divide XL with omega. So XL is 4, J4, and the omega is 10. So this is 0.4 Henry. Henry, yes. Okay. And then next for XC, capacitive reactance. So the formula to calculate capacitive reactance is 1 over omega C. So now we want to calculate what is C. So the 1 divided by omega XC. So our omega is 10 and XC given is 1. So this is 0.1 farad. Okay. So, yep, under the same group, which is under basic group, so you can select the inductor first. So inductor, we need zero point 0.4, or maybe you can write down 400 milli, is the same. Okay, so this is 400 milli. And then next, we need capacitor. So select this one. And then the value of the capacitor is 0.1, so maybe you can either key in 0.1 or 100 milli. Okay, so place at here. Right, so now we need to connect all the components. So maybe highlight this first and move to center. Okay, so this one move here. Okay, yep. Now we can connect all components. So just move close to the lake, and then it's already appear this wire. Okay, connect to here, and this one at here, and this one to here, and this one to here, and lastly this one connect to reference node ground, here, and lastly here. Okay, so now we already construct our circuit. Then next we gonna analyze the uh, variables that we need to find. Okay, so for this case, the question asks you to calculate what is V1 and V2. So V1 is and V2 is the voltage at node 1 and node 2. So basically we are measuring voltage V1 at inductor, and V2 is at capacitor. Or also you can measure V2 at the resistor, since these two are in parallel. Okay, so you can parallel voltage should be the same lah. Okay, so maybe we can put add-on probe here. So just select this one, and then the other one add here. Okay, so we can rename, I think we can rename the can we rename it? Let me check. Oh yeah, can we rename this? Maybe we can rename as voltage node 1. Okay, and this one should be voltage node 2. So since we want to measure voltage at this node, the value should be in phase polar form. Okay, so we need to measure the magnitude of the voltage and also the angle of the voltage. Okay, so it's the easiest way. If you use the multimeter here, this multimeter is only measure the magnitude value, so the angle is not measured. So the easiest way is by using the single frequency AC. Okay, so go to simulate and select to analysis and simulation. Okay, at here you can you choose the single frequency AC, and then enter the frequency. For my case, the frequency is 1.592. And then the output, we want to measure it in so you can either measure in real and imaginary, or magnitude and angle. Okay, so we are going to measure it in phasor domain, polar form. Okay, so select magnitude and phase. And then next, um, you have to change, you have to set the output that we want to measure. Okay, so for this case, um, we want to, okay, these are the variables that that available for you to measure. So we want to measure voltage at node 1. So this is the sorry, so we want to measure voltage at node 1 and voltage at node 2. Okay, and then click run. And so this is the results. Okay, oh, I forgot. Yeah, well, before that, you need to enter, yeah, I forget to enter the voltage, to set the voltage and voltage source before V1 and V2. Okay, so for V1, um okay, so the voltage given here is 75. So this is 75, and then the angle is 0. Okay, so frequency at here is 1.559, 1592. Okay, and then what else you need to key in? Peak value. So this one, since our measurement will be in RMS, so make sure that the AC analysis magnitude, you have to include the RMS. And then for the peak one, you should enter the value in peak. Okay, so to get VRMS, from the formula, peak divided by sec2. So now we need to calculate what is peak. So we have to multiply with sec2. So 75 multiply with sec2. So this is 106.066. Okay, and then next, for V2. Okay, so V2 given this is 100 voltage and the angle is 60. Alright, and then next you need to key in this 1.592 frequency, and then the voltage peak. So we take 100 multiply with sec2. So this is 141.42. Okay, that's all. Alright, so now we can run the simulation. It's either you would click at here, or you can just simply choose this one and click run. Okay, so this is the results. So value that measure should be RMS. Okay, so we assume that the question provide the value which is in RMS. Okay, So yeah, maybe we can compare with our answer that we calculate. Okay, so V1 is 96.8. Okay, um, and the angle is 69 point. Okay, so this is correct. And then V2 is 16.89 and the angle is 165. Okay, so this is correct. Okay, so let's say if you have to measure the okay, for the example, you need to measure the current at this capacitor and voltage across this capacitor. Okay, so you can select the uh, output at here. So maybe yep, this is the voltage across the capacitor, and then you can select current flow at this is the current flow in the capacitor. So select this one and click run. Make sure that you choose the right variables to measure. Okay, so this is the result. Okay, all right, so this is the current and this is the voltage. Okay, so since our capacitor is 1 negative 1 J, okay, so the value should be the same lah for magnitude both V and I. Okay, according to Ohm's law, V equals to I multiply with X. So since our current is the same, so our voltage should be the same. The only thing angle will be different lah. Okay, so voltage, since we are measuring voltage and current at capacitor, so the phase angle between the voltage and current should be differ by 90 degree. So you need to check this whether your current and voltage is the phase difference should be 90 degree. Okay, alright, so that's all for this tutorial. Okay, so next class we will go through on calculation for one example. So I will perform calculation for all methods that we already covered so far. Okay, alright, see you guys on Wednesday.